Hello and welcome back. In this short session we will talk about nested sets, the empty set and the power set. Let's start with the empty set. An empty set is just what it sounds like, just the curly brackets with no elements inside, and we can use this crossed out 0 notation. So crossed out 0 denotes curly brackets with no elements inside, or the empty set. Now, a special property of the empty set is that it is a subset of any other set X, even if the empty set is not an element of that set. Let's think about that for just a moment. The reason for this is when we take a subset of a set, we take the container, or the brackets, along with 0 or more elements of that set. And if we choose to not take any elements, we still end up with the container, or the empty set. So the empty set is a subset of any set X, even if that set X does not contain the empty set as an element. Now let's talk about nested sets. Nested sets are sets that have elements that are other sets. So sets inside of sets. And let's start with the idea of cardinality. Remember, cardinality of a finite set is a count of the number of objects it contains. And I've written here an example of a nested set, and I'm asking how many objects it contains by putting those vertical bars on each side of it to indicate the cardinality of it. Now what we have here is a set of which the first element is the empty set, and the second element is a set containing the empty set, and the third element is a set containing the empty set as well as another set that again contains the empty set. So we have various levels of nesting here. But importantly, the first objects we encounter, or the only objects that we encounter inside this set, regardless of their level of nesting, the number of them is 3. We have that first empty set element, a second set element containing the empty set, and a third set element that is also nested. The number of elements here, however, regardless of the level of nesting, is 3. So it doesn't matter that the objects of our set here, the elements of our set, are also sets. We still count them as individual objects, no matter what their level of nesting is. We are now ready to discuss the final concept of this session, and that is the power set. The power set of a set X is simply the set of all subsets of X, the set X. Now remember, the empty set's always included, so we already know that the empty set is an element of the power set of the set X. And I will also tell you that the entire set X is also an element of its power set. So we know that the power set is a nested set. It's a set of sets that includes the empty set as well as the complete set, and then any other subset, partial subset, that is non-zero in size, in cardinality. So as an example here, we have the set A that contains 3 elements, the numbers 1, 2, and 3, and I've written the power set below it. So it contains the empty set. It also contains the individual elements of the set inside of a set. So the elements 1, 2, and 3 in their own sets, as well as all possible pairs. Those are the pairs 1, 2, 1, 3, and 2, 3, and the whole set. And that completes the power set. Now the number of elements of the power set of a finite set turns out to be 2 to the cardinality of the set. So 2 raised to the cardinality of X is the number of elements you'll find in a power set. In this case we have 3 elements, so we have 2 to the power of 3, or 2 cubed, which is 8 elements in our power set. Let's do another quick example of a power set. Let's do the power set of the Boolean domain. Remember, the Boolean domain just had 2 elements, so we know its cardinality is going to be 2 to the power of the cardinality of B, which is 2. So we got 2 squared, or 4 elements in our power set. And we know that those must include, so our power set is a nested set that must include the empty set as well as the entire set, which is the Boolean domain itself, is an element of our power set. The only other 2 elements in there are going to be our individual elements wrapped in their own sets, for a total of 4 elements in the power set of the Boolean domain. Let's summarize. We saw the definition of the empty set. We saw nested sets. We also looked at cardinality of nested sets, the number of elements. We saw that the empty set is a subset of any set X, even if that set itself is empty. So it does not need to contain an empty set element, but the empty set is still a subset. And then we talked about the power set of a set X and the fact that both X itself and the empty set are always elements of the power set of some set X.